Hey GED students. I had a student, Shayna, who was struggling with the concept of remainders, and a lot of students struggle with this. In fact, this is like the third or fourth time this has come up with me for GED students in the last couple of days, so I thought I'd throw out this little video. I was on YouTube with my long division video on YouTube, got this comment, like somebody really mad at me that I would ever do a problem where I had remainders. And they said, this is useless. Students don't understand it like this. They understand it better when it's a decimal, and you need to redo the way you teach math. And I was like, I'm sorry. There's a time and a place for everything. And as it turns out, there's a time and a place for remainders. Let's take a look at this problem and see what I mean. Okay, it says Chloe is baking cookies to sell in boxes of 12 cookies. If she bakes 112 cookies, calculate the number of boxes she can fill and the number of cookies left over. So I have a lot of students who see this and they go, oh, look, I know the total number of cookies that this woman has. She has 112 cookies. And I know the group size, basically, we're going to put 12 cookies in a box. So if I want to figure out how many boxes, I'll just go ahead and divide. I'll take the total, divide it into 12 groups of 12, right? 12 in this box, 12 in that box, 12 in that box, and that will give me the number of boxes. Now, many of you reach for your calculator right now, but I'm going to warn you, I would not reach for my calculator for this problem. I'll explain why in just a little bit, but notice, they didn't just want me to calculate the number of boxes she can fill, they also wanted me to calculate the number of cookies left over. The number of cookies left over. Okay, so let's take a look at the division if we did this with long division in our case. So 112 divided by 12 is the same as 12 into 112. So I switch the order for long division. Now, a lot of you guys don't know your 12 times tables. That's okay if you don't. You can just count by 12s down the side of your paper. 12, 24, 36, 48. Let's see if I were to add another 12 into this. I'd go up to 60, 72, 84, 96, 108. Okay, so how many 12s am I looking at? 1, 2, 3, 4, 5, 6, 7, 8, 9 12s. But 9 12s is 108. And you can see that I have some leftovers. Now, this problem right here, whenever you reach the end of your division, but you have a remainder in the world of division, you have options. You have the option, 3 options basically. So let's talk about what your 3 options are when faced with remainders in long division. I'm going to erase this here. And super important that you understand these options because different ones work at different times. Option number 1 is leave the remainder. Meaning that I have 9 of something with 4 left over of something else. And we'll talk about what those somethings are in this problem in just a second. But that's one option. Second option is to divide with decimals. You keep dividing to get a decimal answer. This is what your calculator does. Usually. Unless you know how to tell it otherwise, and I do. But most of you guys don't. So keep dividing, calculator answer is what the calculator does usually. Okay, their third option is to make a fraction. Okay, but what I want to point out to you is that these 2 last options, keeping a decimal answer or making a fraction, basically convert your entire number. What am I talking about? Well, remember what this was. This was 112 cookies. And this was my 12 cookies per box. This was my group information. So this answer that I'm going to be getting out, this 9 up here represents boxes. Now this 4 I haven't been able to use. So since I haven't used it, I haven't actually done division on it yet, it is still going to remain as a cookie. Those were 112 cookies. Right now I have 4 cookies left over. So this remainder here is how many cookies I have left over that I haven't used up. So what does this math here tell me? This math tells me that I would have 9 total boxes with 4 cookies left over. Now you might be thinking, Kate, well, isn't that what I'd get in my calculator, 9.4? Well, you're making a false assumption. If you were to divide 112 by 12 in your calculator, you actually get this ugly number. It says 9.33333. What your calculator has done is convert this entirely into boxes. It's saying that you have 9 boxes and 0.33333 of a box. Well, I don't know about you, GED student, but for most of the students in my class, 0.3333333 of a box doesn't have a whole lot of meaning. It's more meaningful to know that that was 4 leftover cookies. And so, because they wanted me to know the number of cookies left over, a better way to deal with this would have been remainders rather than decimals. Okay? Now, you might be saying, Kate, I have no idea how they got that 9.33333. Shouldn't they have gotten 9.4? Yes. You know, y'all make false assumptions about the way the remainders work. The remainder doesn't just turn into a decimal. In order to keep getting decimals, you have to keep dividing over and over and over again. Keep doing the division process. If you want more information on that, it wouldn't be appropriate in this problem, so I'm not going to do it. But if you want more information on that, look up a decimal division video. There's a ton of them out there on the internet. But do realize that there are times when remainders come in handy. Let's look at one more example. Okay, let's see. A time when leftovers come up. I know. So let's see. A student in Kate's class is 66 inches high. "66 inches, we don't usually say high. What in the world, Kate? How about tall? 66 inches tall. And I want to know, how tall is that? In feet and inches. Now, again, look at the message I'm sending you. I'm telling you how tall is that in feet and inches. I want part of my answer converted to feet, and part of my answer to remain in inches. This is a big clue that I would rather do my long division by hand so that I can see that remainder instead of having it converted to decimals. So let's do that. Okay, this is 66 total inches high, and I know that each 12 inches represents 1 foot. I hope that you guys know that. That's one fact you would be expected to know for the GED, that there are 12 inches in a foot. So the first 12 inches will be 1 foot. The second 12 inches will be another foot. The third 12 inches will be another foot. Basically, I'm taking 66 total inches and I'm breaking it into 12-inch segments. I'm breaking it into feet. So let's do that. Let's do 12 into 66. Now, once again, counting by 12s to figure out how many there are in 66, I get 12, 24, 36, 48, and adding another 12 to that. This is the work I'm doing in my head. I get 60. So that's 1, 2, 3, 4, 5. 5 feet, 5 12-inch segments. But I didn't use up this whole 66 inches. I didn't use it up. I only used up 5 12s. That's 60 worth. Let's subtract that out to see how many of the inches are remaining. How many inches are remaining? 6 inches left over. Okay, so when do remainders come in handy? Remainders come in handy when I want the leftovers to stay in my original unit. I want my leftovers to stay in my original unit. In this case, my remainder of 6 remains in my original unit of inches. All right, if you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.